Hi, everybody. Mary here, and it is time to start week 7. And this time we're going to talk a little bit about dimensional analysis, the second part of that, density, and primarily this talk, we're going to talk about significant figures and significant digits. The story so far, last week we talked about the metric system, its history, the fact that about 200 years ago there were not consistent digits, so they had to invent this interlaced system of meters, liters, and grams. We started talking about converting units. We've gone through single-step and multi-step conversions. And along the way, as we did that, we did mathematical calculations. And when I was doing example problems, I would round off numbers. And I didn't spend a lot of time explaining why I rounded off, when I rounded off. I kind of did it and said, oh, I'm going to round off here and there. But now we're going to talk about exactly why. In science, there are rules about when you round off and when you shouldn't. And these are called significant digits or significant figures. Both terms are used. So if I was going to divide 133 divided by 7.1, I would get that answer out of my calculator. But what would I write down? How much of this is important? Is all of it important or not? Well, it depends, and that's what we're going to talk about. The Fast and the Furious friends are back to just share with you the fact that what I'm going to talk about here is the quick version. People spend weeks on this in math class, and we're going to give you the quick and dirty overview. Now, some numbers are exact numbers. These are counting numbers, numbers that you count. How many chickens are on the lawn? 3 chickens are on the lawn. How many blue pots? 2 blue pots, said the count. How many donuts? 12 donuts in the box. So if it's a counting number, it's an exact number. And an exact number never limits our number of digits because it's exact. You don't have 2.5 chickens. Ooh, that would be kind of ooky. But other numbers that are exact that do not limit how many digits we round off to are defined numbers. For example, 1 inch is exactly 2.54 centimeters. So that conversion factor never limits how many digits we round off to. Now, those are exact numbers, and there's gazillions of those. But in science, we also have measured numbers. And measured numbers are trickier because there's always a limit to the measurement, and it's based on the tool. Not based on you, the experimenter, but based on the tool. And in science, we try and choose the measuring tool that's going to give us the most accurate and reasonable measurement. So if you were going to measure the height of a child, a ruler would probably be a reasonable tool, but it's not a good tool for measuring the size of a bacterium. And it would be incredibly tedious tool if you were going to try and measure the distance between the Minnesota Vikings and the Green Bay Packers homes. So you got to pick the right tool, and you need to know how many digits you can use that tool to get precision down to, or accuracy down to. Now, the number of digits that are expressed and expresses the accuracy of that measurement, that is called the number of significant figures, or sometimes it is called significant digits. Both terms are used. And this definition is how many digits you round to. How many digits can you write down? How many digits do you put down as a final answer? And so we're going to talk about how do you figure that out. It all starts with the process of measuring. In science, we do an awful lot of measuring with equipment. And when you measure something, you begin with the measuring tool, and you are allowed to measure to the best of your ability, plus you are allowed, and this is scientifically allowed, 1 guesstimated digit. You are allowed to use your human brain to do your best educated guess. So let's practice this. Whatever this is, I want to measure its length using this meter stick. And if I go right here, I want to know what is the size, what is the length of this. So I would say everybody probably agrees it's 41 centimeters. Each one of these is millimeters, so the length is 41.1, 2, 3, 4, 5, 6. Everybody agree it's 41.6 centimeters long, but here's the thing. You are allowed to make one more educated guess, and you might say 41.65. Your colleague might say 41.64. The person next to you might say 41.66. And which of you is correct? Here's the wacky thing. All are correct, because all certain digits, all digits you are 100% positive of, and you are allowed to use your brilliant scientific brain to guesstimate one more. So how many of those digits are scientifically important? 1, 2, 3, 4, 4 significant digits. Let's take a look at this one. This is a pH meter, and you put this into a beaker of a solution. We're measuring the pH of this object. Okay, here's a 6, here's a 7. Let's take a look at our hash marks. We've got 1, 2, 3, 4, 5 between the 6 and the 7. So each one must be 0.2. So 6.2, 6.4, 6.6, 6.8. So I think everybody's going to agree the pH of this solution is 6.8. Certain of that. We're 100% certain of that. Now, we are allowed to guess one more. And you might say 6.81 is the pH. A colleague might say 6.82. Here's what's not allowed. You cannot say 6.815 and say, well, I'm going to split the difference between the two. You can't say that, because that would indicate that you know this precisely and for certain. That is not correct. This is allowed and this is allowed, because by expressing that, in science, you are saying this is a guesstimate, this is a guesstimate. If you say 6.815, you are saying I know all of those for certain and that's my guesstimate. So you have to be very careful how you write data down in science. How many sig figs? 3. This is a graduated cylinder. Graduated cylinders are the measuring cups of science. And when you use them, you put them flat on a surface, you look at them straight on, and liquids have a tendency to form kind of a curved meniscus, it is called, in that graduated cylinder. And you always read graduated cylinders from the bottom of the meniscus. So we're going to read this from the bottom of the meniscus, from right there. Now, what is this volume? This is 50 milliliters. This is 60 milliliters. And each one of these little hash marks is 1 more milliliter. So 51, 52, here is 53. So we are certain this is 52 milliliters, and we can guesstimate one more. So you might say 52.8, and your colleague might say 52.7, and a colleague might say 52.9. All of those are acceptable. What if somebody said 52.75? Is that allowed? Nope, not allowed, because you are guesstimating too many digits. How many sig figs? 3. There are rules for counting sig figs, and when is this important? And as we continue our mathematics with converting units and density and other things here in this class, we'll practice this as we do our calculations. But here are some of the rules for counting sig figs. Preceding zeros don't count. They're just placeholders. So for example, in this one, there are only 2 significant figures. These others are just placeholders. Zeros in the middle of the number do not count, do count. So how many significant figures here? There are 6. Trailing zeros, they can or cannot be significant. If there is a dot at the end, that's an indicator that all of the digits in front of them should be included. If there's no dot, they should not. So in this situation, there are 4 significant figures. In this situation, there are 1. What if you've got something in between? How do you express it? Well, that's why scientific notation was invented. So if I said 5.0 times 10 to the third, that would indicate 2 sig figs. And if I said 5.00 times 10 to the third, this would indicate 3 sig figs. So that's the beauty of scientific notation. Trailing zeros. If you're going to write it down and it is smaller than 0 and it's going to be at the very back end, only write it down if it is significant. So that would be 4 sig figs. And again, scientific notation is useful. So this would be 9.710 times 10 to the negative first if there were 4 sig figs, or 9.71 times 10 to the negative first if there were 3 sig figs. And exact numbers, like counting numbers, 1 dozen is 12, unlimited number of sig figs. Now, do not stress about this. Don't stress about this. We're going to go through the basics. This is one of those big topics. We're not going to go into massive detail. All right, let's go try this on our own. So how many sig figs here? 5. How many sig figs here? 3. The preceding zeros don't count. How many sig figs here? 1. The preceding zeros don't count. All right. Okay. Hit pause. Try these and we'll go through them. All right. We're back. How many sig figs here? 2. Here, 1. It would be 4 if there was a dot. There's no dot. Here, 3 because of the dot. Here, if it's written down, it should be counted, so 3. 2, 3 because it's scientific notation. That makes it easy. Love scientific notation. And 5 sig figs there. You will have questions like this on this week's study guide. Math rules for significant figures. When you do math with measurements, here's the big thing. You cannot have more digits in your answer than you start with. So if I multiply those 3 numbers together for volume, length times width times height, I am going to get an answer of 56.3355 cubic centimeters. So how many digits do I round off to? You cannot have more answers in numbers in your answer than you started with, than the smallest number of sig figs you started with. Which one had, this one has 3 sig figs, this has 2, this has 3. The smallest number I put in the calculation has 2, so I have to round this off to 2, 56 cubic centimeters. The rest of this stuff, I call it calculator diarrhea. It doesn't really matter. It is poopy that comes out of the calculator that it's good for nothing. So it doesn't matter. Math rules for sig figs. Guys, please don't stress. This sweet lady looks stressed. There are so many more rules for calculating sig figs. We're not going to go into them. Why? This is not a math class. And truthfully, math classes can spend a week on that. We're going to just worry about this. Never end up with more digits than you start with. And we're going to go all the way back. I've got a little more time. I want to go back to the very first question. Boom, ba-doop, 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 ba-doop. So you aren't wondering. Let's see if we can answer this question before we stop. So how many sig figs? How should I round this off? 133 divided by 7.1. This had 3 sig figs. This had 2. I should round this off to 2 because that's the smallest number I've got. Round that off to 2. That should be rounded off to 19. Okay? Don't stress. As we go through the problems and example problems, I'll be doing this all the time. You'll pick it up. You will. Trust me. Have a good one, and I'll see you later. Bye-bye.